Okay, so this is part 2 of the lesson on 5.2, which is proving quadrilaterals. Proving that quadrilaterals are parallelograms. And so at this point, you should have made an attempt at each of the 4 practice problems to determine whether or not, based only on the given information or the markings, whether we could prove that the figures are parallelograms. And again, your conclusions should be based on the markings in combination with theorems 5.4, 5, 6, and 7, which highlight the ways in which you can prove that a quadrilateral is a parallelogram. Okay, and so now to the solutions. The first example hopefully is relatively obvious. Both pairs of opposite sides of the parallelogram are congruent, and therefore by virtue of theorem 5.4 we have got ABCD is a parallelogram, and so we've got parallelogram, or rather using the notation would be better, parallelogram ABCD, and that is based on theorem 5.4. Okay, second example. In this case we have one pair of opposite angles congruent to each other. Despite the fact that the figure is drawn to look like a parallelogram, you are not given any more information than that, and so you cannot make any assumptions about angles B and D, and so in this particular case we cannot prove that ABCD is a parallelogram based only on the markings that we are given, and so in this case we need to say no. Again, if you made the assumption that angle D was a supplement of angle C, that would have been a false assumption. We do not know that for sure. Alright, if we go on to example 3, we have one pair of opposite sides marked as congruent. We have one pair of angles marked as congruent. These congruent angles also allow us to conclude that BC and AD are parallel to each other. This by itself does not allow us to conclude that ABCD is a parallelogram. There is a theorem that says if one pair of opposite sides are both parallel and congruent, then it is a parallelogram. In this case, we have one pair is congruent and another pair is parallel. We are also unable in this case to prove congruency of triangle ABC and triangle CDA. We have an angle, we have one side, we have a reflexive side, but as you can see from the markings, we have SSA and not SAS, the included angle, and therefore in this case we do not have enough information to conclude that this is a parallelogram. Okay, to example 4. Here we have our parallel lines. We have angle D and angle A are both marked as 90 degrees. If we use the property of parallel lines that says same side interior angles are supplements, we should be able to ascertain that angle C is a 90-degree angle. Similarly, using the exact same reasoning, angle B would also be a 90-degree angle, and we're now in a position to say that this is a parallelogram ABCD, and that is because we have both pairs of opposite angles are congruent. And so if we go back to the previous page, if both pairs of opposite angles of a quadrilateral are congruent, the quadrilateral is a parallelogram. And so our reasoning for example 4, or problem number 4 rather, is theorem 5.6. Okay, so hopefully you were able to get those correct and or at this stage understand them. You now need to turn your attention to the assigned work, the B-level assignment. Work through that, and once you're completed then your final task for the day is to get your laptops out and work through the midpoint quadrilaterals GSP activity.